Alrighty folks, so here we are, we're looking at the mean value theorem for today. This is one of our homework checkers that we all bombed on, so boo to us. It says, can the mean value theorem be applied? And if so, find the value of C that makes this statement true. So just to clarify, this here is the mean value theorem. Okay? And what the mean value theorem says is that, I'm going to write it down again here, so it's just to be clear here. Over B minus A. So this here is the average rate or average value. What the mean value theorem basically says is that the average rate is equal to the instantaneous rate at some value C, where C is contained. This little symbol here means contained from A to B, okay? Which is the same thing as saying, like, if you have like a curve here, right? Okay, and let's just say you have a point A and you have this point here B, right? If you wanted to find the slope here, the slope of these points here, it's basically saying, like, there's a point C here such that at C, this slope is the same as this slope. That's all this is saying over here, okay? And so how do we know that this is true, okay? Oops, we need blank sheets. There's a couple of things that we need to check here. Who remembers, if we remember here, there's two conditions you need to check. So condition one is that f needs to be continuous on AB. So it has to be continuous on A to B. This means there's no jumps or asymptotes. The second one, f must be differentiable. Means I can take the derivative on A to B as well. Okay? So if we look at our problem here, my problem, if you look back, it was f of x was 1 over x minus 1. Now if you note, and this was on 2 to 4, if you note this one here, this here is discontinuous because everyone should know this is the reciprocal function or rational with the vertical asymptote at 1, true? And it looks like this. So it's discontinuous for every for one value in its domain. However, from 2 to 4, is it discontinuous? From 2 to 4, it is continuous, right? So it has to be continuous on its domain. So it satisfies 1. So f is continuous. Okay? Now, is it differentiable? Absolutely. Why? Because there's no spikes, no asymptotes, anything. So f is also differentiable. So this means that I can apply the mean value theorem here. So if we recall, it is f prime of C equals f of B minus f of A over B minus A. So then I'm going to plug in everything I know. So, and if we remember from the problem, this is A and this is B, so we plug it in. So f of 4 minus f of 2 over 4 minus 2. And we remember f of x is just 1 over x minus 1. So 4 in here is going to be what? 1/3 minus 1 over 2. True? And 1/3 minus 1 is going to be 2/3 negative over 2. And that just becomes negative 1/3. True? And then so this is this piece here. Now be clear. This piece here is equal to this piece, right? So now all you need to do is just find the derivative and set it equal to it, right? So we're going to do that. We're going to do that right now. So f prime of x is low, d high is 0, minus high, d low over low low. So you get negative 1 over x minus 1, the quantity squared, equals negative 1/3. I'm going to cross multiply. So I get negative 3 equals negative x minus 1, the quantity squared, divided by negative 1, square rooting both sides now. So you get plus or minus the square root of 3 equals x minus 1. Now if I just add 1, x equals 1 plus or minus the square root of 3. So these are the values where it has the instantaneous rate of change that's equal to the average rate of change, which is 1/3 over here. Okay, and that's how we do these problems.